Section 1.4 is where we're going to start to explore angles. In this section, we're going to learn the parts of angles. We're going to talk about how they're measured, and once we measure them, how we classify those angles. First of all, let's start with a ray. This is the ray AB, and remember we denote it as a B with the ray sign over the top. That is, it starts at the end point of A Now let's say we're given a line. This would be the line EC or ED or DE, several ways to name it. I'll call it the line ED. On this line, since C is between A and D, we actually have several rays here, but I want to focus on two of them. One is the ray CE, and again, that is going to So just as opposite rays were formed from a common endpoint, we can also put two rays together with a common endpoint, but they don't have to be going in the opposite direction. Let's look at these two rays. We'll make a common endpoint here of, we'll just call it B, and one of the rays is BA, and we'll make the other ray, make that a C, sorry. That will be the ray BC. And so we have two rays that are not going in opposite directions, but they're shared, or they share this common endpoint. And that gives us our definition of an angle. An angle is formed by two non-collinear rays with a common endpoint. So this picture up above now constitutes and probably the most important part about angles is how we name the angles. When we name an angle, we have to name it with three letters. So in the angle up above, The other way we can name an angle is sometimes we just put a little number in here. I'm going to use the number 4. Oftentimes in a picture, we'll have many angles in the picture. And instead of naming it with 3 letters, we have a shortcut. And that is we can just use the angle. So the other way we could name this angle would be or. We could just call it angle 4. Now those numbers will be given to you in your homework problems. You can't just make up a number to throw in there whenever you want. But if it's numbered in the problem, they're identifying it as an angle. It's kind of a shortcut you can use. Another part of an angle we want to discuss is if we took another point. So let's first of all say that we have the angle XYZ. So I'll write that down here. This is the angle XYZ. And I'm going to take another point. And for our purposes, we're just going to call it the point P. If I put the point P right on one of the rays, we say that the point P lies lies on the angle. Okay? If the point is on one of those rays, it lies on the angle. And I could do that with several other points. If I wanted to take a point Q, I could say that point Q is on the angle. Let's try another point. Let's take the point J. And we have the point J. We say that J lies inside the angle or in the interior because this would be considered inside of the angle. All this that I'm shading would be inside. So the point J lies, I keep spelling lines, let's correct that, lies in the interior of the angle. Running out of room, so squeeze it in the interior of the angle. Now if I scroll up just a bit, looking at that same angle, we'll take one other point and we'll call it B. Here we would say B lies in the exterior of the angle. It is outside of the angle. So the point B lies in the exterior of the angle. Exterior meaning outside, interior meaning inside. So that's the concept of points that either lie on a line The next thing we want to do is we want to be able to give angles a measure. Just like segments had a measurement, a segment was 2 inches or 4 centimeters or 3 feet. Angles are also measured too. Angles are measured in degrees, and that's what we're going to use in geometry. When you get into trig, we'll talk about different ways to measure angles, but for our purposes, we're always going to measure angles in degrees. And to do that, we use the tool called the protractor. And I've got a picture of one on the slide. And when we use a protractor, note that there are 2 scales to use. One of them starts at 0 and goes towards 180. The other one starts over here at 0 and goes along the outside to 180. And you have to be careful which one you're using when you set it down to measure the angle. All right, let's start with an angle. I'm going to just draw an angle. Let's make it look like this. And we want to find the measure of the angle. Well, I can take the protractor over here, and when I go to measure it, I make sure that, and let me point to it here, all right, in a new slide here, we want to measure this angle. A couple ways to do it. I just have to make sure that this is going to be a little tougher because it's not, I can't really see the vertex. So I'm going to put it about right there, noting that one of the angles, in this case, so once we can get an angle measure, then we're going to classify angles by their measures. And there's three ways to classify angles. One way to classify an angle is as an acute angle. And an acute angle is one whose measure is less than 90. So it's a less than 90 degree, there's our degree sign, angle. So an acute angle might look like this, or this, or even that. But they're all less than 90 degrees. The next kind of angle would be a right angle. And a right angle, we've all heard of this before. It is exactly 90 degrees. Not 89, not 91, but exactly 90 degrees. And we have a notation for that so that we don't have to every time wonder if it's 90, and that is we put a little box in the corner. We make a little square out of it. That notation is an obtuse angle, And an obtuse angle is an angle that is between, or its measure is between 90 and 180 degrees. Now, it can't be exactly 90 and it can't be exactly 180. So example of an obtuse angle would be like this. And sometimes we call them big angles. But their measure is between 90 and 180 degrees. Both of these would be considered obtuse angles. The last thing we want to discuss on the video is what an angle bisector is. And we'll go through the definition of what an angle bisector is. Now, the first thing we're going to talk about is that it is a ray that divides an angle in half. Let's take a look at that. That's not technically the correct definition, but let's at least address this. Let's say I have an angle, and it looks like this. If I'm going to cut it in half, the angle bisector would be the ray that would cut the angle in half. So if the original angle happened to be 70 degrees, then each of the little angles, now here and here, would both be 35 degrees. An angle bisector is that in our case up above, both of the angles are 35 degrees. Those would be congruent angles. And if I were to name those, let's say that this was angle 1 and this was angle 2, we would say that angle 1 is congruent to angle 2 because they are both 35 degrees and they both have the same measure. So for our definition of an angle bisector, we could add on to that it's a ray that divides an angle, and that should be angle, sorry about the typo, that divides an angle into two congruent angles. And in fact, that is the definition that's more correct, I would say, that an angle bisector is a ray that divides an angle into two congruent angles.